So now that we know what logarithms are, at least in a small sense, we're going to take and graph them. So we start with a parent function, log base 2 of x, and in order to graph that, we're going to have to pick numbers that give me clean answers out, and that's going to be the challenge of this. So once again, we know logarithms mean what power of the base is the number. So in this case, x is our number, and we want to pick numbers such that we can answer what power of 2 is that number. So I'm going to start with an easy one like 2. What power of 2 is 2? 1. Then I'm going to go to another easy one. What power of 2 is 4? So notice what I'm doing. I'm picking powers of 2. Now another one that we always want to use is 1. What power of 2 is 1? Well, anything to the 0 power is 1. And we can also say that we have some other powers of 2, like, a half, for instance. And I know that's the -1 power, and a quarter, that's going to be -2. Now the question is, can I use a number like -2? What power of 2 is a negative number? Well, if I take any positive number, raise it to a power, will I ever get a negative number? And the answer in this case is going to be no. You can also ask, well, what if I said 0? What power of 2 is equal to 0? Well, 2 raised to any power, either positive or negative. If I make it a big positive number, it goes huge. If I make it a big negative number, then it ends up being a very small positive fraction. So this will never happen either. So let's take a look at a sketch made by these points. If I go over 4, up 2, I'm here. If I go over 2, up 1, 1, 0, 1 half, -1, 1 quarter, -2. I end up with a graph that looks something like this. And you'll notice in this case that the graph goes up forever to the right, and it goes down forever but stops at this point. It can never go negative. So in this case, my domain is x is greater than 0, and my range is all reals. So now we're going to take and use our translations, and these work the same as they have in every other problem that we've done. Again, we have a parent function of log base 2 of x, which we just graphed. So I know I have some points of 1, 0, 2, 1, 4, 2. We went 1 half, -1, 1 fourth, -2. And we have an h value equaling -1 and a k value equaling -4. So if I go over 1 and down 4, there's that starting point, and I'm going to do that same pattern of log base 2 of x. So go over 1 up 0, over 2 up 1, over 4 up 2, etc., etc. And there's my graph once again. Notice goes up and down forever, so my range once again is all reals, and my domain in this case, notice it's going down forever right here and never going past this stopping point. So my domain in this case is x is greater than -1. So in this case, we're going to a parent function of log base 3. We'll need to pick some different numbers in this case. I have an h value equaling 6, k value 2, and in this case I have an a value or a y multiplier of 2. So now, remember, what power of 3 is the number? So I'm going to need to pick powers of 3 for my number x. So 3 is a good number, 9, 1, 1/3, 1/9. What power of 3 is 9? That's the second power. What power of 3 is 3? That's the first power. What power of 3 is 1, 0, -1, -2. This right side is going to be pretty similar all the time. But now we're going to multiply all these y values by 2. So I have -4, -2, 0, 2, 4. And I'm going to do that from 6, 2. So here's 6, 2. From right here is where I'm going to do all these graphs. So I go over 1, up 0, over 3, up 2, over 9, and up 4, over a third, down 2. This is where it gets kind of sketchy. Over a ninth, and down 4. So when I graph it, very similar look to what we've been doing. Again, going up and down forever, so my range is all reals. My domain this time, notice the graph doesn't go past this vertical asymptote here, so that's going to be x is greater than 6. Again, we've got an a value, but it's a negative, so h is 1, k 8, and a -1. New parent function of log base 5 of x. So in this case, we'll pick powers of 5 because we want to know what power of 5 is that number x. So 5 is a good one. 25 is probably a little bit big. I could use it, but probably not going to. 1, 1/5, and 1/25. Power of 5 is 1, that's a 0. Power of 5 is 5, 1. Power of 5 is 25, 2. -1 and 2. We're going to multiply all these by -1. So I get a -2. Whoops, I lied. I get a +2, +1, 0, -1, and -2. And I do all that from the point 1 and 8. So I go over 1, 0, over 5, up 1. Don't have room to go over 25, so I'll go back a fifth. Oops, I lied. Did that wrong. Over 1 up 0 is fine, but now I go over 5 and down 1. Then I go over a fifth and up 1. And over a 25th and up 2. So this graph looks something like this. Oops. But again, you'll notice, even though I'm multiplying by a -1 to all the y values, it still goes up and down forever. So my range is still going to be all reals. But my domain in this case doesn't go past this vertical line here, so that's x is greater than 1. So here's the case that we all hate, where we have this b value thrown in here and it's not in the proper form because I need a coefficient of 1 right in front of that x, so we're going to have to factor. We have much tougher parent function, log base 1/4 of x is equal to y, so we're going to have to pick powers of a fourth. which isn't that bad because it's really like picking powers of 4. We just got to be a little careful when we do it. And we have to rewrite this by factoring once again. So y equals log base 1/4 of, I'm going to pull out the 2, get x minus 3 here. So y equals log base 1/4 of x minus 3 over a half. So identifying our terms, we have h equaling 3. Our b value is equal to a half, so that's our y multiplier. And now we're picking powers of a fourth. So certainly 1/4 is a power of a fourth. What power of 1/4 is 1/4? That's 1. Well, if I square 1/4, I get 1/16, so I'll pick 1/16. And what power of 1/4 is 1/16? That's 2. Again, we said 1's always a good number to pick. Anything to the 0 power is 1. Now we're going to pick 4. What power of 1/4 is 4? Well, that's a -1 power. And then 16 is a -2 power. And we're going to multiply each of these by a half. So in that case, I have an 8 here, a 2 here, half, an 1/8, and a 32nd. And I'm going to make all those jumps from the point 3, 0. So if I go over a half and up 0, I'm right around here. Let's use a different color. If I go over an 1/8 and up 1, right around here. Over a 32nd, up 2, about here. Over 2, down 1. And over 8, down 2. My graph is like this. Range, once again, goes up and down forever, so that's all reals. Domain doesn't go past this vertical, so that's x greater than 3. Last example for the day. We've got both an a and a b term. Let's rewrite it. Y equals 4 log base 2. Factor out the 1/3. 1/3 times what is equal to 2? Well, that's 6. And so I now have y equals 4 log base 2 of x plus 6 over 3. So I have h of -6, a of 4, b of 3. And my parent function is one we've used before, so log base 2 of x equals y. Pick powers of 2, 1, 2, 4, 1/2, 1/4, -2, -1, 0, 1, and 2. Going to multiply by 3 to the x's, giving me 3/4, 3/2, 3, 6, 12, and multiply by 4 to the y's, giving me -8, -4, 0, 4, and 8. So I'll move over 6. And start graphing. We have 3/4 over and 8 down. Puts me right around here. 1.5 over, 4 down, 3 over, 0, 6 over, 4, and 12 over 8. Go ahead and sketch that out. Notice it's stretched out both vertically and horizontally. And once again goes up and down forever, so my range is all reals. And my domain doesn't go past this vertical, so x is greater than -6. And that's all we've got. Go ahead and do your Connect Ed, fill out your survey, and we'll get back to you tomorrow.